record. Okay. I think you're going to find it's not as bad as you might think. Hopefully. Okay, so they just send you this and kind of do it, or there's some sort of instruction.
Yeah, they have like a lesson, but like I already did it. You do a lesson, then there's like a correlating assignment.
I see. Okay, so let's just start. If I do something like this, like, I don't know, x plus 2 equals 5. Do you know what x is equal to?
3.
Yeah. Okay. So you're not like totally, you don't know what they get. So basically a variable is just a placeholder, right? Meaning, okay, what number plus 2 equals 5? So did you do that just by sight? Like, yeah, I know 3 plus 2 equals 5.
Yeah.
Like that. Okay.
Yeah, I don't need as much help with this where I'm at right now because it's kind of simple. It's just like sometimes I make like if like in like the bigger equations, like the longer ones,
Oh, okay.
I make like small mistakes.
Okay. So what about something like this? What's the first thing you would do to solve this?
Subtract 5x from both sides. No, it's wrong.
Well, no, you could do that. You can always do whatever you want to both sides of an equation as long as you do the same thing to both sides. So that wasn't wrong.
I
It
do
might
like
not
to
be.
make one on the other side though. So I would subtract 2 from both sides.
Good. And what do we get on the left side?
0.
And then what's left?
What?
What's left on the left side?
Oh, 5x equals 4x minus negative 9 plus 2. Oh wait.
It's okay.
Negative 11.
Good. What was going?
Negatives.
What was going on in your head when you were trying to get negative 11?
It's because for some reason I was looking at it like it was a fraction because of the line.
Oh, okay.
In my head, and then I was like, wait, that's not a fraction. Why am I doing fractions?
Okay, sorry. So do you, when you write it out, do you do something like this?
No, I usually do that, but for some reason I looked at it.
Oh, okay.
I think it's just the negative line. I don't know. I don't know what was going through my head.
I get it. So now what?
So
I always pause a while to let you think. So if you're like, just tell me, Dave, you can do that.
No, it's not that. I'm just very tired.
Oh, I get it.
I would say combine like terms, but I feel like that's not the answer.
Yeah, you would. You always start off by combining like terms on either side of the equation. But there's an X term here and then a number, X term number, so we couldn't do anything. So subtracting 2 is good. The idea is always to get your X's or your variable on one side and everything else on the other. So I'm going to move the 4X over here. And since it's positive 4X, I'm just going to subtract 4X. And then 5X minus 4X leaves me with one x, which we just write as x. Is that okay?
Yeah.
And then we have solved it because 4x minus 4x is 0. And then we have negative 11. Does that make sense?
Yeah.
Okay. And then you can always check it, right?
Yeah.
If you wanted to.
And yeah.
Yeah. And then it should make a true sentence. So just real quick, you know, as you get good, there's really, and confident, there's not a whole lot of need to check it. So 5 times negative 11 is negative 55. Negative 44, and your favorite thing, Charlie, negatives like everybody else. So that's going to be negative 53 and negative 53. So booyah, we're good. Oops, look at me. It is early, isn't it? So x is negative 11. Is that okay? Okay. Did you like roll out of bed at 5 to 8?
I woke up at 7.
Oh, okay. Me too, but I hit the alarm. All right. Sorry I started off with that. Okay. So something like this. So before you start adding or subtracting from both sides, you look if you can simplify on both sides, on either side of the equations, combine like terms. On the left side, there are no like terms. Do you agree with me on that?
Yeah.
Okay. And on the right side, we've got negative 3 multiplied by all of this nonsense here, right? So the first thing we need to do is simplify this part. Nothing I can do on the left side. So do you know what we need to do with this negative 3 and the x plus 1?
Negative 3x plus negative 3.
Okay. Can we go ahead and write that as minus 3?
Yeah. Oh, yeah. Because you have to switch the, yeah.
Yeah. Negative times a positive is a negative, blah, 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 blah. So we should see that there, it's the exact same thing on both sides of the equation. So when that happens, that means we can plug whatever we want in for x and we get a true statement because it's the exact same thing. Okay. And when that happens, that means that there's an infinite number of solutions or all real numbers. And if you don't immediately see that, you know, you can just start simplifying, right? Plus 3, plus 3. And so we get negative 3x equals negative 3x. Is that okay with you?
Yeah.
Okay. And then if you don't see it, then you can still go, okay, well, plus 3x plus 3x. Oops, sorry. Plus 3x. And we get 0 equals 0. And that makes sense, right? 0 does equal 0. And so if you boil it down and you get like 0 equals 0 or 3 equals 3, or I don't know, dog equals dog, whatever, if it's the same thing, that means you have an infinite number of solutions or all real numbers. What do you think you would get if there was no solution? Or give me an example of what you might get if you think there was no solution.
If there's like, if you get like an answer and then like you plug it back in and it still doesn't work, or isn't that like an extraneous?
Well, that would be, that would mean you made an error. Like if you got x equals 2 or whatever, and you plug it back in and it's not a true statement, you're very close. But if you get like x equals 2, plug it in and it doesn't work, then you've made an error somewhere. But when there's no solution, so this means all real numbers, which means infinite number of solutions. I'm going to cover this one up and we'll just make another page for it. Okay, so if there are no solutions, you get an equation that doesn't make sense. Or that isn't true. Doesn't make sense. Like, you know, so you're working down, blah, 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 and you get like 2 equals 3. You know, just two numbers that are not equal. -7 equals 12. Okay, that means there's no solutions. But if you get something where they are equal, then it means all real numbers. Is that okay?
Mhm.
Okay. Oh, algebra. Okay, so they didn't even tell us about the toy store. Basically, they're just telling us this is an equation that represents X is what? The number of sale items in the store. So, you know, we just have to solve the equation. So X equals 0.7X plus 24. So what do you think we should do here?
Combine the like terms.
Okay, and do we have any terms that are the same on we only have one term on the left, right?
Mhm.
And there's nothing we can combine on the right hand side. So we need to get all of our X's on one side and everything else on the other. So we've got an X here and an X here. So what should we do?
Subtract X from, no.
You could do that. I think you were saying do this.
Yeah.
Okay, I'm gonna do that.
But then there's no X to equal.
Right, but what you do have X minus X is 0, right? And this isn't the way that I would do it, and I'll show you in a second, but I just want to show you that it doesn't matter what, you can always do the same thing to both sides. That's not wrong. It just might be less efficient. Okay. And so now I have 0.7X minus, there's a 1 in front of here, right?
Mhm.
Okay. And 0.7 minus 1 is actually 0.3X. And it's negative plus 24. And again, the goal is to get your X's on one side and everything else on the other. So I'm going to move this 24 over to the left side. And I get minus 24 equals negative 0.3X. Do those moves make sense?
Yeah.
Okay. So now how do I get rid of the negative 0.3?
Subtract it from both sides.
Close, but we have to look
Or
at
add it to both sides.
again, close, but we have to look at what's happening to the X. This is negative 0.3 multiplied by X. So to undo the multiplication, we have to
divide
use,
it.
there you go. Divide both sides by negative 0.3. And then these cancel. That's the whole reason we do that. And let me just say that the reason they cancel is you have this, you have negative 0.3 divided by negative 0.3. The same thing divided by the same thing is equal to 1 always, which gives us 1 times x, or simply x. And then a negative divided by a negative is a positive. I know that 24 divided by 3 is 8, but because it's a decimal, we're going to throw a 0 on, or we would use our calculator. So x in this case equals 80, but that was a bit of a longer way to do it. So let me show you a more efficient way to do it. Okay, so I have an x on the left side, and then I have an x and just a number on the right side. Okay, so if I gather my x's and get it all by itself over here, if I subtract 0.7x, then over here on the right side, this is gone, and all I have is 24. Do you see how that's a little bit more efficient than moving to the right first?
Yeah.
Okay. And so then I have the 1 in front of the x minus 0.7. And either grab a calculator or, do it off to the side. 1 minus 0.7 is 0.3. Does that make sense?
Yeah.
Okay. And then since 0.3 is being multiplied by x, I undo the multiplication using the inverse operation division. And then these cancel because they equal 1. And I get x equal to 80. How's that? How's that feel? Does that feel understandable?
Yeah.
You seem a little hesitant.
Oh, I don't know. I didn't think it would be 80 because I was like, how is 24, if 80 is more than 24, how is 24 being divided?
Oh, I see. Well, it's like how many 0.3s are there in 24, right?
Yeah.
So there's got to be a whole bunch, doesn't there?
Yeah.
Since it's a little thing. So that's what's happening. So your confusion is totally normal, by the way. This is when people start algebra. These are the things that trip them up. So hopefully we're going to be able to clear them up. Okay. I'd like you to try one. Okay. I'm
Okay.
going to give you one similar. So let's say we had 2x equals 1.4x equal to, oh, not equal to, come on, Dave. I don't know, plus, let's say 18. Go ahead and give that a whirl. Do you happen to have like a writing pad, like an online writing pad?
Oh, I have a piece of paper.
Oh, okay, cool. And if you need to use a calculator, go ahead.
Okay.
Does Florida Virtual let you do that? Or
Yeah.
do they say? Yeah.
They let us use calculators.
Yeah, then do it. Charlie, I have to warn you, I almost said it's totes fine to use a calculator because I think it's hilarious to say totes because it's so cringeworthy. especially for like an old person to try and be cool. So that's why if it slips out, I just do it on purpose. Forgive me.
Gatsby, stop barking.
Oh. What's the doggy's name?
Gatsby.
Oh.
Hold on, I have to redo it. I did something wrong.
That's okay. Don't scratch it out because I'm going to ask you to send it to me so I can see what you did. Okay.
Okay. Okay. I got x equals 30.
Booyah. Sweet. Can you, I want you to take a picture and text it to me, but can you make sure it's okay with mom or dad before you do that? For you to have my number and for me to have your number?
Okay.
I just
Um,
always check.
They're not here.
Okay,
I
well,
can't ask, but I can tell you what I did.
no, I'll go ahead and give it to you. I'm assuming it's okay. And if not, you know, I can just delete it later. So that's my number. That's really great that you caught your mistake. How'd you know you did something wrong?
Because I was doing this and I was like, this is way too complicated.
Yeah, good. When's your, so do you have a due date for that assignment?
I just have to finish by the end of the week.
I see. Okay.
I don't even know if I did anything wrong. I just kind of got bored of what I was doing and I realized
That's That's fantastic. Go
I was
ahead and
gonna
send it to
say-
me though, just so I can see, Charlie. It's good for me to be able to see because it helps me understand how you might be thinking. Yay. Yep, that's a common error. Oops. You have nice, neat handwriting or writing, which is a huge plus. Did you hear about Sweden? Like the country? The flag's a huge plus. It's a,
Oh,
it's
I think
a
that's
horror.
Switzerland.
Oh no, is Switzerland the one? My first attempt at a bad joke and I blow it. Okay, I'm glad you showed me this because this is a common error. So the rule, okay, so let me just write down quick the rules for solving an equation. So first, one, simplify both sides of the equation. That means like combine like terms. Or do you know what I mean? What I mean when I say distribute?
Yeah.
Like multiplying the 3 or distribute. Which means multiply through parentheses. Okay, 2. Always first, add or subtract first, sorry for yelling, to move numbers, variables to other side of equation. And then the third thing you do is multiply. It's like the order of operations. Multiply or divide depending to move numbers. Variables to other side of equation. And then simplify as needed. Does that make sense reading through it?
Yeah.
Okay. I did not say Sweden. It's just embarrassing. So I can subtract, I can't simplify, I'm subtracting. You did this. Divide by 0.6. Are you pretty good about keeping things in line and whatnot, being very neat about it?
Yeah.
Okay, that's great. Okay. All right. Next one. We might as well just go ahead and solve this. Just looking at it, what would you do first? After me giving you those horrific rules.
Hold on, let me do the equation.
Okay. Give me 1 sec. I'm just going to put these over here.
Add 6 to both sides of the equation and divide by 2.
You got that right, Charlie. 2x equals 28. And what'd you get?
X equals 14.
Good. You feeling a little better?
Yeah.
Okay, good. Okay. This is kind of a tougher one. So what happened? What happened from step 1 to step 2?
They combined like terms.
Good. Are there more choices, or is this it? Oh, I'm sorry. Look, they started here. I'm so sorry. Right? So the original equation is up here. So what did they do to get from here to step 1?
They distributed the 1/2 into the parentheses.
Excellent. So distributive property. And then they combine, you already said they combine like terms, so that's good. And I'll just abbreviate. And then what? And you don't have to use these words, just, you can just tell me.
They moved the 2 to the 6.
And how did they do that?
Oh wait, no, they didn't. They added the 2 to get rid of it.
Yep.
Both.
And I think you spoke correctly when they added the 2 to the 6. If you meant that they moved the 2 to the 6, if you meant that they added it. So,
Yeah.
I mean, you don't have to remember these exactly, like they added. Well, that's the addition property of equality, which is a fancy name for saying I can add or subtract the same thing to both sides of the equation. If we wanted to, we can make our lives miserable and add 1,000,000 to both sides, and we would still solve and get the correct answer. Then what happens?
They divide.
Boom.
Yeah.
Correct. They divided both sides by 9, right?
Mhm.
And that is the division property of equality. So whatever, I don't know which one it is. So it's this one or this one, distributive, like terms, then they added, then division. So it'd be this one. Do you agree?
Mhm.
Okay. Okay. Oh, so I think, can you select more than one on this?
Yeah. It just cut
Oh,
off.
okay. So, one is correct. Would you agree?
Yeah.
What about reason 2?
I think that's correct.
This kind of makes me mad. And I'm curious to see if you get it right or not, but they subtracted 10. Right? So it was plus 10. This plus 10 is the same, and the only difference is they subtracted 10 from both sides. So that would be the subtraction property, property of equality.
Oh.
Does that make sense?
Yeah. Because I was looking at I was looking at the step and I was like, oh, the step is correct, but
Yeah, yeah,
the reason isn't.
yeah. So they're asking if the reasons are correct. Okay. There is an argument that you're adding at -10, but whatever. So this is wrong. Okay, and then how do you feel about step 3?
I think it's right. Yeah.
Good. They just took 10 minus 10 and 40 minus 10. Okay, what about step 4?
Um, it looks right, I guess. I
Yeah,
really don't.
what did they do? I mean, just from here to here.
You flip the equation. It looks
Yep.
like.
They flipped they multiplied by the reciprocal.
I mean, the fraction. Yeah.
Okay. Which is the same as dividing, right? Like if you took 3/2 and you divided by 3/2, if you remember your awful days of learning fractions, right? This is
Mhm.
equivalent. Are you okay with that?
Yeah.
And then it turns into that, right? So they just skipped all this nonsense of division and immediately multiplied by the reciprocal, which is a little easier, or saves a step. So that's good. And then what about step 5?
Um, it looks fine.
Yep, it's correct. And I misread it. They asked which one is incorrect. I thought they said which is correct. So that would be reason number 2.
Yeah.
Okay. All right, almost done. How are you with fractions, by the way?
Fine.
Really good. Okay, what do you want to try this one on your own?
Sure.
Okay. I'm gonna get up and get some water. I'll be right back, okay?
Okay.
I lied, Charlie. I'm getting coffee and water.
Okay, I did it.
Okay, what's the first thing you did?
I multiplied both the sides by 4.
Oh my God, brilliant. To get rid of the fractions.
Yeah.
So something like this.
Yeah.
Okay, then what happens on the left side?
It got simplified to 3x plus 5 equals 16x.
Charlie, you're killing it.
Yeah.
Now what?
I moved 16 to the 3x. So I subtracted 16 from both sides.
Okay. And
And then I got negative 13x.
uh-huh.
Oh, yeah. And then I moved the 5 to the other side too, so negative 5.
You did it all in one step.
Yeah.
That's
So
cool.
I ended up with negative 13x equals negative 5.
And then
I divided both the sides by 13 to get rid of the number and for it to just be x, and then
uh-huh.
5 over 13.
Charlie, that's fantastic that you know how to clear the fraction. I didn't realize that you know how to do that. That's outstanding.
I didn't. I just thought they were all 4s, and I was like, let's just multiply this by 4.
Yeah, you know what you're doing. The only thing I would suggest is at this step right here, and it'll save you, it saves you one step. Instead of bringing the 16 over here, it's okay to move the 3x over here. And that way, you immediately just have one thing on both sides.
Huh.
You see the difference?
Yeah.
So then the Kapow theorem, and you get 5 over 13 equals x. Just a little tiny bit less work. What you did is totally fine. It's just like one extra step. I just realized I skipped number 3, so I'm gonna go back to that. I think I covered it up to give you some long, boring lecture.
No, we did number 3.
Did we?
Yeah, it was 80.
Oh, okay. Cool. What was this? Yep,
What?
okay. Yeah, we did that. Oh, no, we didn't. This one, see? X plus 16 over 3x.
Then what?
I think the number was covered up on this one and it was number 4 up here. It got cut off. And we didn't do that one.
So that one's 3. So then
Yeah,
what? One that was 80.
that was 4.
So everything just moves down.
Yeah. And then this should be 5. Yep. 6, 7, 8.
And then which was 5?
This one. And I'm gonna send you all this, Charlie, so.
Okay.
Right when we're done, I'll send it as a PDF. I'll email it to you. What's your email address, by the way?
Oh, it's. Hold on. I changed it so I don't.
Yeah.
Okay, it's Charley _ Smith, CHARLEY _ Smith at windermereprep.com.
Oh yeah, they started doing the names, huh? Oh my God, windermereprep.com.
Yeah.
Okay. All right, I'll email it to that when we're done. And then later I'll email a link to the video. So when, instead of Netflix or something, you can rewatch algebra. I don't think anything's better than that. All right. So this one's a little different than what we've done so far. We've got x plus 16 over 3 is equal to 3x. So what should we do first here?
Um, hmm. I don't know.
Okay. Um, so what is happening with the x plus 16 and the 3?
Being divided by 3.
Right. So this is an exception to adding or subtracting first because there's nothing I can add or subtract that's going to help.
So do we multiply by 3?
Yep. So then we can clear that 3, right? So 3 times x plus 16 over 3 equals 3x times 3. And then these cancel out because this is really like 3 over 1. So they can cancel out. And we're left with x plus 16. Is that okay?
Mhm.
And that's going to be 9x. So what would you do next?
Um, get the x over to the 9x somehow.
Nice. So then we have 16 equals 8x. Now what?
It's 2 because 8 times 2 is 16.
Good. I like to put the step because things get a little bit more complicated and we can't always do it in our head. Okay. All right, we got a few minutes. Let's look at number 9. And 10. I tell you what, I'd like to just stop and see if you have any questions. And what I will do is I'll finish these and send them to you in your notes. It'll just take me a few minutes. But I'd like you to try them and and then just use my work to check. Does that seem okay?
Mhm.
Okay. All right. And so, any general questions, Charlie?
No.
No? Do you feel a bit better about solving equations?
Yeah.
Okay. So what I always tell my students is if you would like to see me do things differently, if you're not following me, then you need to let me know because my job is to help you as much as possible. Okay. And I think that this is going to be our time weekly. I'm not totally sure. Is that what mom said to you?
I think
Or,
so.
okay. But if you have, if you have anything that comes up before then and you need my help, just have mom shoot me a text, or if she allows you, you can shoot me a text and maybe we could try and find, even if it's just like 10 minutes, we can just pop on and I'm happy to help you out. Okay.
Okay.
All right. Okay. So once this is done, I'll do 9 and 10 real quick. I'll email you those notes. And then once the recording is done, I'll upload it and send you the link. Okay.
Okay.
All right, Charlie, it's nice to meet you. I'm excited to work with you. Have a good day.
Thank you too. Bye.
Bye-bye.